Welcome to Let's Do It 511. In this LDI, we're going to take a look at side-by-side comparative box plots. Side-by-side comparative box plots are used all the time in the real world to compare two or more populations to each other to see if there are differences between those populations. So let's start off with taking a look at the LDI 4.23 data that we generated, which was the left-hand, right-hand, or right-hand, left-hand data. So to do that, I'm going to get my calculator out. This is from our previous LDI where we took a look at the age data. And I'm going to go into the stat plot menu. I'm going to go into plot 1, leave it on, leave it as a modified box plot, but I'm going to change the list to be the right-hand data. Okay, once I've done that, I'm going to hit my up arrow until I highlight the plot list on top here, switch over to plot 2 by highlighting it and hitting an enter, turn that plot on, change it also to a modified box plot, and then make the list my left-hand data. Now I'm going pretty quick here, but you can rewind this tape and watch it as many times as need be until you get the idea of it. I'm going to go a little slower when we actually use the data they asked for us to do in the LDI. Okay, once I've got that all set up, I'm going to go ahead and do a zoom and the number 9, and I get two side-by-side comparative box plots, where if I hit trace here, I notice I am on the right-hand box plot here, and notice we have a couple of outliers. There's a minimum at 67, which is an outlier, and a maximum at 120, which again is another outlier. One thing to notice though is that the median here is at 95. Now if I hit the up arrow, I'll land over on the left-hand box plot, and the median there was at 60. And what we notice here, this is the main thing I want you to see, is that the measurements of center appear to be dramatically different for these two distributions. And that comes at no surprise. Most of the people participating were right-handed folks. And so we would suspect that on average, the number of boxes that you could X out with your right hand would be more than the number of boxes you can X out with your left hand. Another thing we notice is that we've got an outlier at 104 on the left-hand data. Well, clearly that must have been somebody who has a left hand as their dominant hand, and so they had quite a few more boxes they successfully X'd out with their right hand. Okay, excuse me, their left hand. All right, let's go take a look at what the LDI wants us to do. In LDI 511, so on page 321 of your textbook, they want us again to look at the amoxicillin and the cefadroxil groups that we looked at earlier. This time, though, they want us to make side-by-side basic box plots for the age, for the data above, the age data above for these two drugs. Then they want us to use the 1.5 times interquartile range rule to determine if there are any outliers for either group. So they're going to ask us to do the side-by-side box plots both as basic box plots and as modified box plots. So let's get after that. We're going to need to bring our calculator in here. Let's go ahead and close off the big screen for a minute. And what I'm going to need to do is I'm going to need to enter all of those data that are present in here in L1 and L2. Okay? So I'm going to move my calculator off to the side for a moment, and I'm going to go ahead and go into Stat, go into Edit, and I'm going to go over and, well, let's just see what I'm doing here for a moment here, is I'm going to go ahead and get over into L1 and L2 and clear out any data that I happen to have in there. And remember, to clear out a set of data, you highlight the list name and press Clear, and then say please or hit the down arrow. Either of those work. Highlight the list name, press Clear, hit the down arrow, and now the list is emptied out. Okay. All right, so I'm going to get this off to the side so I can see all my numbers, and you play along at home here, okay? So first number I'm going to put in is 14, 17, 11, 10, 11, 14, 9, 12, 8, 10, and 9. Okay, so that's my 11 from the amoxicillin group. Now the cefadroxil group, which goes into L2. 9, 14, 8, 10, 13, 7, 9, 11, 16, 10, 12, and 9. Okay? All right, so let's bring the calculator back in now so you can see what I'm doing here. Get it back over there, and we'll open up the big screen so you can see what's going on. So notice I've got in L1 the amoxicillin group and the cefadroxil in L2. So let's go ahead and go back to the stat plot menu. And let's change, because the first round they want us to make these standard or basic box plots. So let's change them back to basics box plots. And then my X list will make that L1 for the amoxicillin group. Okay? All right, now here's a trick. You may not have followed with me on the last time I did it, but it's a very cool trick. As you notice that there's plot 1, plot 2, and plot 3 up here on the top. If you hit the up arrow, go over and highlight plot 2, and hit an enter, it'll take me into plot 2 automatically without having to go back through a second y equals. It's kind of a nice trick. Okay, again, leave it on. But let's go change the plot type. Notice I'm hitting the right arrow to get over to the plot type I want. And let's change the X list to L2. And we're good to go. Let's do a zoom and a 9. Okay, and what we notice with these two groups is they're, looking that compared to what I just showed you with the right-hand, left-hand data, they're looking remarkably similar. Okay, if I do a trace here, we see that the median was 11 in the amoxicillin group, and the median was 10 in the cefadroxil group. So not a real drastic difference in the medians between the two groups. Okay, in fact, there's little evidence to suggest that these two groups are really distributed differently. Those two box plots are close enough looking like each other that it's hard pressed to say there's any difference between the two. All right, now they asked us not to just investigate them as side-by-side basic ones, but they said go ahead and take a look and see if there are any outliers. So we're going to change the box plots to be not only inclusive of all the information that you get out of a box plot, but also to say something about any possible outliers by switching them to a modified box plot. That's the only change necessary here. I don't need to change anything else. Into plot 2 now. I'm going to change that one to modified. Okay. Once I'm done with that, let's go ahead and hit a zoom and a 9 again. And we notice there are no difference in the box plots between the basic box plots and the modified box plots. So what that tells us is there is no outliers in the data either, no unusual events. So punchline is this, is that they did a good job randomizing the ages between the two groups, and age could not be considered as a confounding variable in this study. Okay? Alrighty then, so that takes care of LDI 5.11, and I'll see you all back here for the next one.